In this video, we'll take a look at how to predict solubility for an ionic compound in water. Solubility is defined as the extent to which a substance dissolves in a solvent. Here, we'll make a couple of simplifications. First, we will approach solubility as an either-or situation. Either an ionic compound is soluble or it is not. Second, we will only consider water as a solvent. A compound is soluble if it dissolves in water and creates a homogeneous solution. In a chemical equation, we would note the phase of the ionic compound as aqueous, written as AQ. A compound is insoluble, which means not soluble, if it does not dissolve in water. The mixture is heterogeneous because it consists of two separate phases, a solid and a liquid. In a chemical equation, we would note the phase of this ionic compound as a solid, written as S. Be really careful not to note a soluble compound as S. S stands for solid, not soluble. So let's look at how to predict and justify solubility using a set of solubility rules. And we'll start with the example of silver chloride. First, we identify the cation and the anion from this compound. So we have Ag plus and Cl minus. Then we look in the first column only. We don't look in any other column but the first column, and we try to identify at least one of the ions from our compound. So if we look at this first column, we'll notice that we don't see silver, but we do see chloride. So then we look across this row until we find the term most or all. So if we move horizontally to the right, we find that we have most, and most refers to soluble. So what this tells us is that most chlorides are soluble. Then we look at the other column. So now we're looking over here to see if our other ion is an exception. So we were looking at chloride, now we need to see if the other ion, silver, is an exception. And it turns out that it is, right here. And so what this tells us is that when chloride is combined with silver, that compound is insoluble. So silver chloride is insoluble because most chlorides are soluble, but silver is an exception. Let's take a look at calcium nitrate. We'll write the ions Ca2 plus and NO3 minus. Then we'll look in the first column only to see if we find our ions. And we notice that we do find nitrate, but we don't find calcium. So now we look in this row and we find that all nitrate compounds are soluble. If we then look for the exceptions, we'll see that there are no exceptions because there are no compounds that are insoluble. So calcium nitrate is soluble because all nitrates are soluble and calcium is not an exception.